Welcome back to UVA Data Points. I'm your host, Monica Manny. In today's episode, we're bringing you a panel discussion about the future of data science education, which was recorded live at our recent Datapalooza event. This panel delves into how the faculty at UVA's School of Data Science is actively working to craft a liberal arts curriculum suitable for the digital age, one that not only adapts to, but embraces change in technology and in practice. The panelists have a wide-ranging discussion on data science education, including K-12 programs, UVA's guiding philosophy for its undergraduate and graduate programs, and the merits as well as challenges that arise when constructing a new educational curriculum for a new discipline. So with that, here's the future of data science education live from Datapalooza.
I'm pleased for this session to introduce essentially our educational brain trust here in the School of Data Science. And to talk a little bit about where is the future of education in data science headed. And it's a very unique point in time. And I have some questions just to prompt some comments from the panelists, but I don't think there's anywhere else in the country where an entire school is being built around an entirely new discipline. There are, of course, schools that are stood up and you rethink your education and you rethink your curriculum as you go through, and there are routines for doing this. But this is an opportunity to not just rethink about what you would traditionally teach, but what do you teach? What is data science? I think as more and more data science programs get stood up across the country, and almost everyone's unique, it's good to talk about what we're trying to do here, but also what we think, how this fits together, and how what are the essential elements of data science as we go through. So I just want to introduce our panel real quick. So we have, running down the order, we have Prince Afriyie, who is heading up our MS in data science, and he oversees the residential in-person portion. Next to him, all right, so the orders of the circles and the panel are not the same. Next to him is Tom Stewart. He is directing our Ph.D. in data science. John Kropko is directing our MS in data science, the online portion, which have a couple hundred people online. And at the end, we have Brian Wright, who is our program director for our undergraduate programs. And as I think many of you heard, we will be starting our BS in data science next year, and we're currently running the minor. So I wanted to give each of you a chance just to introduce yourselves a little bit, and a couple quick thoughts on what it's been like over the last couple of years. Some of you are just starting, so Prince is just starting, but to have responsibility for a new program for which there is not general agreement in the community over what's taught. Just if you would we'll go down the line, just talk a few minutes, and then I have specific questions that I'll pose to the group. So Prince, do you want to just start?
Yes. So thank you very much. Thank you all for coming to this session. So I think about data science as, and I think I'm going to probably steal Brian's line here. Brian always is famous for talking about data science as the liberal arts education in our generation. I think data science is not a pipeline, but in my mind, I think about it as a watershed. So we have a lot of different students from all backgrounds coming to data science. And so the question now is, especially in the master's program, how do we make sure that we teach all these courses so that we're able to reach everybody? And I think that is the primary thing about data science education in the future. How do we get to everybody? And that might mean like having a very innovative curriculum where we think about, again, reaching a broader audience, increasing participation in data science, and also it can be different modalities of teaching data science. It could be online, it could be in person. I think another thing that we are doing very well here is hiring people with all backgrounds in our discipline in data science. At the School of Data Science, we have people from anthropology, history, media studies, statistics, that's my background. And so trying to bring a team that will reflect the student body. And so I think about this as a very big opportunity to have these, so one advantage would be like even team teaching the class. Another advantage will be like trying to make sure that students can learn at their own pace. It could be an online session, for example. So broadly, I think about data science as watershed, and we can get into the nitty-gritty coming up.
Okay. We'll get into some of the nitty-gritty as we go through. So Tom, do you want to go ahead?
Sure, yeah.
Introduce yourself.
I'll just say that one of the joys of being in a new school like data science is that, my next door neighbor is a network scientist, and then next to them is a mathematician, and then beyond them, is an economist. And I think that's one of the hallmarks of our educational programs here in data science is that it's actually being put together by folks from all the different domains of data science. And I think that's a huge, huge plus. It comes definitely with its challenges. I think I like to say that we all speak the same language, data science, but we speak it with very different dialects. And that just requires a lot of patience as we kind of try to create a shared vision about what these educational programs should look like. And when you ask the question of like, what's important for this process, I think, and at least in my mind, being willing to iterate and try things out and potentially fail, but to adjust and keep pushing these programs towards something that we can all be proud of.
So I should probably give a little bit of the history. So Prince is taking over a program that's been in existence for about 10 years. So this is a Master's of Data Science. It's a 3-semesters program that we run for a year, and it's mostly a more traditional data science analytics focus. And Tom, you're running the Ph.D. program, which is a couple years old now, and that's with a program with a very broad scope of what it means to be in data science. So it's not, and that's one of the things we'll talk about, is not just machine learning. It talks about students learn about all the domains of data science. For those who are not familiar, the school has a vision about what data science is, and it's more than just machine learning. So machine learning is a portion of that. Part of what we call the analytics section. There's a systems part, which is high performance computing, understanding how systems work, interact, how data is stored. There's a domain that we call the design domain that is focused on human-computer interaction. You can even think a little bit about how we store and collect data. What's the design of that? How do you design experiments? And then there's another portion, another domain that we call the value domain, which covers ethics, policy, data governance, data justice, impact to society. And so, for example, in our PhD program, students can focus in one of those areas, but there's a very broad curriculum in the first year or so students get forced and introduced to all of that rather than doing a lot. So let me continue with the introduction. So John, you run the online program, which is been around just as long as the residential program, right? So
it came about a couple years after the residential program began. But so the online MSDS, the whole point is to reach a community of students that the other programs can't reach, and that's people who are working full-time and who aren't in a position where they can uproot their lives and move to the small college town in the middle of Virginia. So, data science being a new field, very few people have degrees in data science. Like maybe that'll change in the future. I mean, we're going to generate a lot of people with degrees in data science. But as of right now, there's a huge number of people who are working in industry who are being tasked with performing data science in their day-to-day jobs, but they don't have the degree in data science, right? They would like to advance in their career, just like all of us would, right? So what is the opportunity to do so? Online education is a really important facet of education. We reach a tremendous number of people who can't live that college life. We have to take that seriously, and we have to give them a very high-quality education while understanding that, hey, it's online, right? Things don't work quite the same. Can we meet people where they are, provide a good education that is over Zoom, that they pursue in the evenings after work, on their weekends? Can we respect people's time and personal sacrifice if you're giving up all of your weekends and all of your evenings for this kind of thing? I mean, think about all the life moments you miss out on in order to pursue this dream, right? And to advance and to meet your personal goals. Can we do that? Can we be kind to people who are trying to achieve this while also helping people feel like students should feel, like part of a university, like a UVA student, somebody who cares about the basketball team, stuff like that, right? So that is the trick, the challenge that I don't think globally online education has really mastered, right? How do you meet people where they're at while also fostering that sense of community? That's what we try to do.
Okay. Thanks, John. Brian.
Yeah, all right, great. That's a hard act to follow. You're so passionate. I love it. You're the right man for that job, I feel like. So I'm the director of the undergraduate program. The only currently existing program that we have students enrolled in is the minor. We have 700 students, which is the largest minor at UVA by, I think, twofold. No big deal. And then we have a new Bachelor of Science that's coming out next year. That's a 3-year degree. So the definition of data science, as it relates to the undergraduate curriculum, the way we see it will be defined through that degree. And there's an equal balance to what Jeffrey was talking about in terms of the curriculum in each one of the areas. So there's no more analytics classes as there are ethics, or data design, or systems. It's equally balanced. With our idea is to do exactly that, is to give students a broad exposure to all the topics that we feel are important for them to be functioning data scientists. So as it rolls out, I think in large part is a manifestation of the school's ideal of what data science is, and UVA being largely an undergraduate institution, so it's important to have a foot in that space. So we're really looking forward to it. I think it's kind of the last cog in the school as it relates to maturity. So I'll start next year. So that's it. Thanks.
Okay. So that's exciting. One of the things I chose not to do was put the curriculums up of each of the programs. I thought that was a little too narrow for what we are trying to do. So as people think about what data science education is, there are broad existential questions about what do you have to know and what do you have to learn to be a data scientist. And I didn't want to focus so much on the requirements as I did sort of the feel and the vision for the panel. So one of the things, I pulled some discussion points, and then I put a couple of my thoughts in questions in red, and this is for the panel. So UVA has now been standing up several new degree programs. In the last couple of years, it's been a Ph.D. and a B.S. to complement its existing MS programs in data science. And so I wanted to ask, how do you characterize the school's guiding philosophy for standing up a brand new educational program quickly, for which there is no other model, right? That you can't pull. So there's a lot of that iteration that sort of Tom talked with that, and to talk a little bit about the challenges in developing or maintaining these programs that are unique to the data science domain, because the curriculum is not necessarily specified. So who would like to go first?
I'll give 2 words, right?
Okay, yeah. Tom. So for the PhD.
I think for the PhD program, our goal is not to rebrand an existing program. We don't want our PhD in data science to just be rebranded statistics or rebranded engineering, right? We want it to be bespoke, custom to the demands that our students are going to face when they leave the program. So I would say, at least for the PhD program, that's one of the guiding philosophies is custom for the students that we're attracting.
And how do you handle, so traditionally, like a lot of PhD programs are very narrowly focused, right? Mm-hmm. You get narrower, and so if you're custom, that sounds almost the opposite, broad, right? And so how do you handle issues of, or how have you been handling issues of preparedness, and what backgrounds do you take, and how do you move somebody forward in the program? What are the benchmarks? How do you do that in a way that's custom?
Yeah, well, it's definitely a challenge, as you know well. But you're absolutely right. We do attract students from a wide variety of backgrounds, and we want students from a wide variety of backgrounds. It just means that we're going to have to create different pathways or stepping stones into the PhD program. Right? Somebody that comes to us from systems engineering who has a lot of technical ability is going to enter into the program at a different point than, say, somebody who's coming to us from the humanities. and needs to develop some of the foundational skills that was achieved, for other students in their undergraduate program. So I think it's creating different points of entry and being okay with that, and being encouraging that, so that we can attract a wide variety of students.
And so how's the experience been working with faculty who come from all over as well, and trying to agree on, what's the base?
Well,
I would just hang it all out there. Yeah, I mean, so what's...
Sit around, in faculty meeting, and you ask everybody, okay, what should a PhD in data science look like? And the statistician describes a statistics degree, and the engineer describes an engineering degree, and everybody just describes their own experience as what they think a PhD in data science should be. And I think we have to intentionally avoid doing that, right? Because that's just reinventing the wheel. That's reinventing a program that's already been developed. And we need to, again, getting back to that custom, right? Making a program that's not just a remashing, but really specific to what our students need.
So, Brian, I know just similar problems, or similar challenges, I should say, when starting up the bachelor's. And so what does it look like? And so how do you pull people together behind, a vision or from some?
I ask for their opinions, ignore them, then do what I want. So I think it's an important point at the, just kidding, obviously. It's an important point of the evolution of the field of data science, right? Because I think over the last 10 years, if I can just, do a little historical context here, we really saw a dramatic expansion relative to graduate, especially master's programs in the field. And that's largely because I think that's the easiest space to stand something up. So to Tom's point, usually those courses are stood up and they're like, let me give it a stats class, let me get a computer science class, let's put that together, and then we'll call it data science, which is fine at that period of time. I think right now where we're at this inflection point where we need to stop just grab bagging courses and say to ourselves, what do we really want this field to be? What is the body of knowledge that best represents this unique domain? We have our own school of data science. Let's define what it is. So, and we've done that, and we did the work for that. And so when we go to design the undergraduate curriculum, that's the perspective that we started with, a blank canvas. And the minute you do that, it gives you a certain amount of freedom to actually envision what the degree should be through the lens of the collection of people that we have involved in the process, which is really, it's just a lot of fun, to be honest. And so as compared to just taking courses and trying putting it together, we just didn't do that. So like even for the math courses, we created a unique mathematics curriculum that's tailored to the field, all right? So computational probability, which is a course that Tom and others are teaching, actually comes first, right? In a lot of educational programs in the undergraduate space, you don't get probability to way towards the end. But for us, it's really important, so we put it in the front. And so we created a mathematics and data science course as well that pulls out certain concepts from linear algebra and calculus that are really important. We did the same thing for systems, all right, for design as well. So we created kind of this unique courses, and we have the luxury to, I'll stop, I feel like I'm wandering on, but here we have the luxury to do that because we have our own school and we didn't inherit any biases from other departments, which is pretty unique in the entire country. To Jeffrey's point, there's only a few places that actually can do that. Most of them are taking existing departments and putting them together. So for us, I actually think it was a little bit easier because we had this blank canvas that we could stand up. Now it requires a lot of discussion, a lot of really lengthy emails about what math should be taught, So there's a lot of discussion, which is what you want, in the situations where you reach out to faculty members and there's kind of a very large silence, then you're worried. But we haven't had that experience at all. So it's been great. And I think we just have to keep in mind, that we are creating something new and that we're not going to get it exactly right? But we've been given the luxury to be able to do that, which is really very unique in education settings generally, to be able to have a new school, a new space, and new degrees that you can uniquely define. It just doesn't happen that often. And if you combine that with the idea that data science is in such high demand, it's a really fun time to be there. So, yeah.
And then I don't know if either Prince or John, you want to talk, but I know while the program's existing, John, I know we're actively expanding some of the tracks in the online program, and Prince, we are re-examining the curriculum, sort of waiting a year to get the bachelor's up and going, so we're not doing everything at the same time. But again, as you're thinking about expanding these programs, are there things that sort of you want to add to, about what it's like for revisiting these curriculums or adding in?
So the residential master's program was here when the school, it was not a school yet, it was an institute. And so because of that, the way we define data science, which the school's 4+1 model, the courses are currently mostly analytics. And we have at least one course from each of the domains. We are currently thinking about revamping everything. And it's going to take a while to get to that point, especially with a big undergraduate population coming in next year. But we are thinking to redesign the whole thing so that it encompasses the definition of data science in the 4+1 model.
In terms of redesign, online it's a little bit tricky because you put all of the course material online, and it's like you've written a book, so the course is taught through that material, and then you meet with the students to facilitate their journey through that material. But if you're going to redesign things, it's a huge administrative burden. Are you going to re-record all the videos, or going to rewrite all of the code examples, and all that stuff? So yes, you have to. The trick is just how do you run a program in which you have sufficient time and energy and resources and attention to redesigning the courses, whether that is big or small. Big in that you want to redo the entire curriculum and introduce like a different paradigm of how we progress through this idea of data science, okay. Or small, like we're going to use a different library for machine learning now. Nobody uses that one, they all use this one now, so we've got to redo all of our slides and everything. Both of them are huge tasks. So for us, it's not quite so philosophical, although the big ideas are very important. It's more, oh Lord, how are we going to do it? There's a lot to redo.
So it's got to be more purposeful, right? As you do that, because you can't just show up and do something different. One of the things I'll say that sort of leads into the next thing is the things that I get asked or talked about is, can the students have more practice with ethics? Can the students have more practice with how this will impact policy? There's very few employers who come to me and say, who's your best coder? In fact, so even here and at Vanderbilt, where I stood up their data science program, I've never been asked that question. But I get asked all the time, who's your best communicator? Who understands models well, and who has the basic principles? And so as we're changing some of the curriculum, we're thinking about this as a school. Is how are we going to generate a workforce that people will hire? Scott, was just sort of talking about people that hire. A lot of companies feel like they can train folks on some technical sides as long as you have a basis, but they can't necessarily train on some of the other people skills or the facility to understand how things impact. And so this sort of gets back to this sort of a little blurb from the session description, which I really like, which was crafting a liberal arts curriculum suitable for the digital age, one that not only adapts but embraces challenges in technology and practice. It gets to this sort of data science, machine learning. And so this got me thinking. I'd like to hear the panel's thoughts about, so what should be in a data science education, right? So beyond, maybe what are some of the key skills, that you're hoping to teach beyond just the technical pieces? What are we also imparting at different levels?
So when I think about data science, I think about our domains are preset, but I think most people think about data science. It involves data collection, which ethics have to come in. It involves data integration. It involves data analysis. And so all of these are part of our definition of what data science should be. And so I think when we have our students live in our program, I want a more holistic person, not just somebody who can just write codes or somebody who could just communicate what data visualization or anything like that, but thinking about values, thinking critically about what they are really doing and the implications of that in society. And so when I think about our students coming from our program, that's exactly, I want a student who is more whole.
I could, you know, when I got all my data training in the classroom, it was all statistics. Like I'm a political science Ph.D. and it was all econometrics and methodology and like that. It was all statistics. And in the classroom, it was almost always, here's a clean data set. Let's talk about regression. Let's talk about all the assumptions that have to be true for a regression to be. But here's a clean data set. And that is such a fantasy world. You know, I think that one of the things that data science can and should do that is maybe a little bit non-traditional in an academic sense is let's give people horrible, messy data that will make people's heads explode. Because, you know, sometimes if you can wrangle huge amounts of data and get it from a variety of different sources, from the Excel file from Hades, or from APIs or web scraping, or various databases, some of which you have to use SQL and some of which you have to use some weird, arcane, NoSQL query language. If you could get data from all those sources and put it together, maybe at the end of all that, all you need is a crosstab. So it's still data science because all of those skills to get the data and to get it in a format where it's usable, vastly important. So and not something that you necessarily always get traditionally in a classroom.
So the data wrangling is part of the scientific process.
Oh, yeah.
And I think that sort of flows through how we think about what data science is. Any other additions before I go to the next? I don't have to have a bite.
I'll just say that we do have kind of a focus on the affective side of terms of the emotional intelligence of the students. You know, when we think about the undergraduate, both through leadership roles and then how they work in teams and how they communicate back and forth with each other, because I think that's an important trait, right? Because in a lot of times these roles are going to be stressful, all right? You might be one of just a few people as a data scientist in an organization because, to John's point, there's still a lot of demand, but not necessarily we're meeting that supply exactly. So I think building in some of those things, you know, teamwork and kind of leadership are important points that we're trying to build inside of the co-curricular activities that students are doing inside the undergraduate, which I think kind of goes to this idea of not just rote kind of skill acquisition, but creating kind of a more enriching, holistic experience. Yeah.
That's great. You guys haven't started asking each other questions yet. So let me try and then think. This is a future, so we're focused on the future. So I was wondering, everyone just sort of assumes data science is the future. If we could talk a little bit about why you think data science programs are the future. You could have a cynical view of, okay, they pop up because people are interested in data science and they want to, they want to make some money, right? Or you could dance. Whatever with this. But so why do you think, and I put just down some things that I was thinking, but I'd like to hear, as you think about your programs, why do you think these programs, I mean, you each had to make a commitment to run a program, so you obviously think it's going to be around. So what is it about data science that's lasting here that wasn't here before?
Well, I'll start out.
Yeah.
I mean, perhaps, the PhD program is probably slightly different than the other ones in that there's a really big emphasis on innovation, right? What is a dissertation in data science? Well, it's an innovation that changes the practice of data science in some way. And, and I think innovation begets innovation in the sense that we have these new, for example, large language models. There's a lot of innovation that needs to happen around that, right? Both in the implementation, but also in the theory. And so, why is data science going to stick around? Because there's so much opportunity for innovation. And I think that's increasing, not decreasing.
So what is it about the data science formula that seems that's so attractive? So I mean, some of these skills are as you talked about, they're elsewhere, right? So people can kind of cobble together the knowledge, and they have been for some time. But there's really been this explosion now where data science is a thing. It's not just the blend of statistics and computer science and some domain knowledge, right? So what's the magic sauce there that you think that makes that different?
Well, I think in large part the demand, at least the origination of the field, really came from like what these roles are in industry, right? So it's unique in an academic sense. Computer science is probably the same way, but like the skills that people were using in the job force needed to be formalized into a field, right? So you have your, Harvard, kind of announcing it's going to be the sexiest job of the 21st century. Data scientists are coming out swinging, and it doesn't appear that demand curve from industry in terms of what the skills that they're looking for has shifted at all. If anything, it just keeps escalating, right? And so I think there's a lot, which is a healthy back and forth, I think, between what we define it in academia in terms of creating foundational skills that are necessary for students to go out and function, but also this just kind of never-ending demand that we get from the industry side about what types of things the students should be learning and what we should be incorporating. The communication skills is a good example, right? The same way. A lot of employers you talk to, being able to communicate the models is super important. Otherwise, they just don't exist, right? And so that's a demand signal we get from industry. So I think that's in part of it. Is that just the kind of the continuous push that we get in partnership with people outside the walls of academia, and then I do think like as the field has matured over time, there's a real body of knowledge there that's starting to develop, and people are recognizing it as a unique domain. And then you have academics and researchers really jumping on board to help further define it. So it's really kind of a natural, I think, partnership between the demand we see in industry and like real curiosity and interest from academia. And those two things don't happen all that often, so it just keeps driving it forward. So that's what I think.
Prince.
So I'll add that, the explosion came from employers looking for data science. And also in our own lives, we basically leave footprints of data everywhere we go. You buy something from Amazon, you watch Netflix, you are actively participating in data. And so people are catching on to this, that I'm giving so much data, I'm collecting so much data, how do I find insights into all of this? And I think that for the scope of data science, to say at the master's level, we should be training students who learn the field of data science is also evolving. Every day there are new tools, new methods that help analyze data. And so how do we also keep up with all of that? So it comes from maybe restructuring the course, even for existing courses, bringing in new tools to let students learn about the new technology that's going on. We're thinking about, there's a lot of demand in, say, sports analytics. How do we design a new course on sports analytics? There's a lot of demands on large language models. How do we think about all of these before other people or other programs actually do that? So how do we get in front of it rather than being reactive to all of that? So when I think about the ideal student or what students take away, learning all these stuff that makes them whole, in addition, learning all the new tools out there for them to be competitive in the job market and even do better when they work at a company.
Yeah, it's interesting as the common thread, as you listen, seems to be this ability to work and function and innovate in an interdisciplinary space. And it's sort of almost a little bit of an opposite direction. Rather than going more and more narrow, you're now preparing people to sort of go in the other way and learn and be sophisticated there. So there have to be some general tools, like you say, that teach. So it's not just about this particular method or that method that goes. Right. So that ability, especially as well in the Ph.D. program, if you think about our students, they're all innovating in some interdisciplinary space, which is exciting. Yeah.
I'd like to. This question, are data science programs the future? No. So it's not the future, it's like a part of the future. So is there anybody here with like social science background? Yeah, like sociology, political science, stuff like that, right? So, okay, there are different methods of research. A lot of that is qualitative. A lot of the most profound insights that come to us from social science are qualitative. That stuff, the importance of that is not going away. I just want to be clear that there's an anxiety out there that data science is coming for your jobs. Man, it's just like another tool in the toolkit. I think of it like this. Coming from a political science background, when we had like 5 data sets that we would just analyze over and over and over, right? We've got one called the American National Election Study. And that's been asked like after every major election in the United States going back to 1948. It's a great survey, but we were analyzing it over, and we've got thousands of articles on the American National Election Study. Well, one of the things that data science does is it changes definition of what is data, quantitative data. Is political text data? Yeah. You know, the last few years, we've had a huge explosion in text analysis leading up to large language models. What about political videos? You know, we've got 24-hour cable news that's all political, right? Audio and, you know, environmental sensing, like the boundaries of what is data continue to expand. And so when we say data science is the future, I think it's mostly data is the future, but there are many different ways to analyze it. It just expands a mission, and there's enough here for everybody. I just, if anybody here has anxiety about like data science is going to be taking over everything else, I just don't think it's true.
We're definitely not taking over everything.
Yeah.
We got plenty to do as we are.
We're not taking over UVA.
Yeah, we're not taking over anything. Just to get back to sort of some more of the discussion points, there's a lot of problem solving that goes on in data science. And you think about, well, how do you develop problem solving, right? It's teaching critical thinking skills, collaborating, communicating. So I think we've talked a little bit about why this is important for future data science, but how have you reoriented your curriculum to make sure that these, you know, to teach these skills, to reinforce these skills, to give students practice at this? I wonder if, Brian, if you want to take a first shot at this as we'll sort of go up the way from bachelor's up.
Yeah, so I think there's a real emphasis on critical thinking throughout the undergraduate curriculum. So one of the mantras that we went into this with, and we have the luxury of space, right, as compared, maybe the Ph.D. has this luxury too, maybe more so in the graduate, less so in the graduate, is that over the course of 3 years, what we're trying to do is less, deeper. So we think that there are foundational things that the students should know really well, and we shouldn't be compelled necessarily just to move forward to the next thing. As a result of that, it gives you the freedom to think of these things in more complex ways, right? And that encourages them, if they have a mastery of these topics, to be able to think about how they apply in situations that aren't perfectly curated, which is essentially critical thinking, facilitating critical thinking. So we have project-oriented courses where they work together in teams. They have to think through problems. I would say I think it's definitely true that essentially you're building kind of problem solvers with data, you know, while we do that. There's an orientation towards active learning, participatory kind of team building throughout the curriculum. So I think it's hard because you're not going to get it exactly right, but we have kind of a genesis, a first principles approach to try and do less topics deeper, and then encourage them to work in teams to think through these topics in a way that allows them to create the analytical agility or whatever that is to pick up new topics and apply what they've learned to the new space, which is really the job. I mean, in all fairness, I mean, most of the time data scientists are out there, you're being asked to do a lot of work that you don't have perfect understanding on, right? So it's a lot of it is teaching yourself how to use a new type of data, you know, teaching yourself how to use a new modality of model, teaching yourself a new system. Because the field moves so fast, it's impossible for us to teach you everything you're going to need. But we can teach you how to teach yourself. And so that's kind of the idea, is to do a little bit less, but do it deeper so they get a real kind of, I said that a couple of times now, I guess, but to get a real kind of understanding of the depth of these topics. And then that allows them the analytical agility or the intellectual agility to be able to do that when they go out in the real world and are confronted with a problem that requires a tool set that they don't know, because that's 100% going to happen. So, yeah.
So just to build on what Brian just said, so I used to teach calculus, and calculus is not going to change. I mean, the application might change, but calculus itself is not going to change. The field of data science, every topic that you teach in there has potential of changing, quite in a very fast speed. And so when I think about the curriculum changes that we're going to be making in the master's program, I want to, similar to what Brian is saying, put in, so I came from a place that the whole model was learn by doing. And I want to encourage a lot of that. I think that students learn so much when they get to participate in their own learning. And so giving the students opportunity to do projects, to dig deeper into data sets and finding more meaning, I think it's going to be, that part is revolutionary compared to the field that I'm coming from, math. And so we want to be very intentional about having students learn by doing.
Okay. Other comments? All right, we'll go on to the next. One of the things, at least that I see that keeps coming up, and I wanted to sort of take this, talk about it at a higher level and then bring it down through a pipeline, was how you handle the variation in student preparedness and the background knowledge. And this has come up regardless of the program, the PhD, the master's, the bachelor's, but also now as the school is talking about preparing students for college education, right? So what's the basics that you need? So that I have those thoughts about the K-12 pathway. So it's a very wide point, but I think it's a really important one. It also changes very much what your curriculum looks like if you don't assume you have one set of uniform. And a lot of times a simple boot camp is not going to bring everyone up to the same place. So I'd love to hear how you've handled the problems you've had and how you're handling some of this. And then we can talk a little bit about how we're working our way into the K through 12 pathway.
I think it's a challenge because we pride ourselves as the school without walls. We want to get everybody in to come learn data science. It's exciting, but also there are some backgrounds that we require, especially for the master's program. There are some courses that's going to require you knowing probability, and so we don't currently have that. So how do we make sure that students are on that level? Some calculus, I talked about calculus earlier, some linear algebra. So we want students to have all these backgrounds before they come in. But there's going to be a lot of, we also attract students that are from not stat, not math, no computer science backgrounds. And so we are thinking about processes to give those backgrounds to the students before they actually start the program. So regardless of your background, you can still come in, but how do we make sure that you're on the same page with everybody in the program?
Seems like that gets harder to do as the programs sort of go up. Like for the PhD program, that's hard to do.
Yeah, I know in the PhD program, a lot of people are actually surprised that we actually have a required curriculum. Some folks are really familiar with PhD programs where you just show up, you start working in somebody's lab, and you just work in that lab until your advisor blesses you and says, okay, you're ready to get your PhD. And at UVA, we've decided to buck that trend and actually lean into kind of the liberal arts aspect of data science and actually have a curriculum that has to span all of the different domains of data science, at least at the beginning, and then give the students an opportunity to really dig in and specialize in one of those domains. And so, the question here of how have we handled that variation is we've required our PhD curriculum to have that broad view at the very beginning. And we have students that come in and who have lots and lots of experience with machine learning, and we said, great, welcome to the program, but guess what? You're going to have to take a data policy and data ethics class, which is something that they may not have anticipated as part of their PhD program. So really leaning into that liberal arts aspect of data science and actually requiring all of our PhD students to have those broad set of skills before they go deep into their innovative work.
So you're sort of shoring some people out, you're smoothing out, but that takes time, right?
Yeah.
Right, and so people have to be willing to take the time to do that.
That's right. And
do you get, because of that, do you get people from broader backgrounds who are applying? I mean, I know you get a lot of students who apply to the PhD program, but are their backgrounds just as broad as you would?
Yeah, I mean, it's always, we're just about to start a new application cycle, and it really is kind of exciting to see the variety, right? We get folks that, you know, are coming to us from religion and humanities and journalism, and obviously we attract a lot of folks from engineering and statistics, but it is a really wide variety of applications that we receive.
I think it has to do with what Brian said, that, you know, the most important skill isn't anything we teach the students. It's helping the students learn how to teach themselves. And, you know, so mostly what you're trying to manage is the motivation, and I think projects go a long way towards that. If you have a good project, there are going to be people who have all this, like, STEM background, coding ability at the outset, but might not know too much about the application of the project. And then there are going to be people who just really care about the project, but might not have the coding or whatever. And then what you have to convey to both people is how important it is to train yourself up on the parts that you still need, you know? So, like our capstones that we do in the master's program are a good example of that. Like, choose some real world application and then do what it takes to get it done. You know, if students graduate not knowing everything, but knowing that they are capable of training themselves and learning what they need to learn and getting done what they need to get done that way, that's a success.
Brian, for the undergrad, I'm wondering if you could just talk about 2 points. One is what sort of background you assume students have, how you would attract them.
Yeah.
Two, I know you often say your goal is to generate undergraduates who essentially are as good as the master's students.
Oh, yeah.
So that we can push the master's programs up, right?
Yeah.
So there's this sort of bottom push. It's the same sort of through K through 12. So if you could talk a little bit about that. I think that's a long range goal for the school. But
long range. We'll be there in 3 years. Pepsi Challenge for the master's program. Bring it on. I think the undergraduates, a large part what we're teaching in the master's program actually translates pretty directly to the undergraduate. And that's because the nature of how the field developed in the master's level. I mean, we teach programming, kind of basic regression courses, databases. I mean, all that stuff can be translated down. The variety of students that we have 700 students in the minor. They come from every major on campus, every single one. I mean, there's probably some unique majors, right, that aren't represented, but it's in the 60s when we count. The polarity of students, the demographics are all across the table. It's majority female, actually, in the program, which is really exciting. So they come from just a huge variety of backgrounds. And to John's point, you kind of work that through in the classroom. A media studies, a computer scientist, and a statistician together make a pretty awesome data science team, right? I had a group do text analysis on all of Taylor Swift's albums, right? And so it turns out she was really mad in like 2012, right? So there's like this fluctuation in her, but it was awesome. I mean, that was the team that did that. And then their ability to be able to communicate it was really just great. So I think I think as much as it is a concern, it's actually a pretty fun opportunity. They learn from each other. And as long as you create an environment where it's healthy and it's trusted and they don't feel pressure to compete with each other, then these kind of organic niceties just kind of emerge, out of that. And to be honest, I think the polarity of the non-conformist nature of the students coming into the classroom ends up being one of the most joyous parts of it, because it can be really fun, because everybody kind of brings their own perspective. It's hard, but it's also awesome.
It's hard.
Yeah.
And the educational model is different very often than what we think about.
Yeah.
So you get more and more specific.
Yeah.
Thoughts about K through 12 and supporting and getting students who come to the university with some of these skills already?
So yeah, I guess I'll start there. So we've been. My background is actually in education, and I think there's some people here in the room that probably know. Robert Clayton and Kim Wilkins probably have done a lot of good work trying to, especially in the Charlottesville area, to develop curriculum and pathways for students. I think, like I kind of talked about the origination of the field was in this graduate. It's starting to move down and up. So we've gone up to the PhD level. We're going down to the undergraduate. It seems to me the next logical step is down to K through 12, which a lot of good work is already occurring. I mean, I think we had our lieutenant governor here for an entire day a few weeks ago, and her major focus was in thinking about creating data literacy, like a campaign around that, and how we could put that into Virginia schools as something as foundational as mathematics and reading and writing literacy, that it should be something that we think about as a contemporary modality for students, which I think is great. So we developed some partnerships, mostly through the education school, the hard work they've done over there, to schools in the area, putting lab schools together where they can come and practice data science and computer science skills. So I think there's a pathway there. K through 12 is complicated, right? Changing these things it becomes as much as an endeavor in politics as it does in philosophy about learning. So it's complicated there. But I think as the field matures and we see more and more kind of undergraduate programs come out, and they are going to skyrocket, I think, in the next 10 years. I mean, I'm aware of at least 4 more just in the state of Virginia that are going to be proposed next year. Then I think there'll be this natural inertia to figure out how we can incorporate communities in the K through 12 into these undergraduate programs. And part of our plan is to take the students when they get up as part of their service learning requirement to go out into the community and teach, if possible, and encourage the next generation of students to get into data science. So we're really looking forward to that. I think that's part of this idea that we're not just training technocrats, but we're training data science leaders, and they have an obligation to pay it forward for the next generation. So the university is really supportive of that, and there's a lot of good programs, a lot of them being driven by Kim and others in the area that allow us to get our students out into the community. So I think, and that should encourage, again, a kind of a healthy ecosystem about how these things bubble up in that K through 12 system. So it's great. We work really close with Albemarle County as well, doing data analysis for them. So anyway, sorry. But yeah.
That's great. Anyone else? Okay, so we have a few minutes at the end. I just wanted to get final thoughts and then open it up for questions if people have questions. So either. Alex, you got to wait for the mic.
So full disclosure, I'm not an uninterested party. I'm Director of Research Administration for the School of Data Science. I'm just asking the panelists to talk about the role of research in data science education.
All right, a natural place to start might be you, Tom.
Sure. Yeah, obviously the research program of the school and the PhD program are very interlinked. And can either be a virtuous cycle or a vicious cycle, right? The PhD program can support the school's research endeavors, or it can take from it. Obviously, we're trying to build a PhD program that is focused on innovation through research, and so we're excited to provide our students lots of opportunities to interact with faculty in research settings as they're trying to navigate who they're going to work with in their PhD in their PhD research. So we from the very beginning, from the very first summer, our students are focused on research and having those opportunities to interact with faculty in those research settings, and of course at the end of the program generate research output that gets published.
In the master's program, the research path I think of with the capstone project. So the capstone project is so open that basically the students get to apply every skill they've learned through the program. Sometimes it's while they're taking these classes on real life data setting that impact business decisions, impact the community and stuff like that. So, and like I think John described this earlier, that sometimes these students don't have the tools for these projects that they're going to embark on. But being able to teach themselves or being able to learn and have a faculty advisor who can guide them through the process, they get a lot from the capstone. They can also get a lot of research exposure through independent study. So as a program director, sometimes I approve an independent study for students, and there's an opportunity there, but also we want the research, like independent study, to be the same rigor as they will have in the classroom. So we have a few students that are doing independent study in the spring for that reason.
Thank you.
Right. Yeah.
My name is Christian Warrens. I work at UVA Health as a data scientist. When we hire data scientists and look at their CV and their application, we evaluate in 3 dimensions. In the classic 3 dimensions you mentioned earlier, it is the coding, computer science, IT ability. Second, math, stats. And third, domain knowledge, including business acumen, but also understanding, in our case, of healthcare. We have about 14 data scientists, some of graduates from your program, but the majority have PhDs in astrophysics, psychology, engineering, all over the place, nurses. So that also, the example you gave earlier on the team of people, that's what we are. And so what my boss actually told me, he's much longer at this than I am, is that he has never found a single applicant who's excellent in all 3 domains. Typically people have weaknesses, and then they're willing to work on them. But do you think, and obviously as a data science school, you're going to teach them very well in math and stats and in computer science area, but do you think that domain knowledge, and I'm not talking just taking a business class, but integrated domain knowledge, in our case, healthcare, which is highly complex, finance, maybe there are other domains where this is the case, play a role in the curriculum in the short time you have with the students?
I could go for
Well, yeah, go ahead. Yeah, go ahead.
I was going to say, the domain knowledge so we have a lot of projects from our capstone from actually UVA Health. So a lot of students get to learn at least specifics for what they have to do their capstones on. So they get that knowledge there. We also have partnership programs. So for example, we have a combination degree with Darden that have students that are getting a master's MBA and also getting a data science master's. We are thinking about expanding this a little bit across different institutions on grounds. And so we are trying to work on this and build on this as well.
In the online masters, we've got already running a course, Data Science for Business Applications, that's been running for a while now. And we're, as you know, we're working to develop a Data Science for Healthcare. And the purpose of these courses is to talk about, okay, so you've learned all these skills, code, methods, all of that, but you need to see how these things apply in this industry, because you could know everything in a textbook academic way and then show up in some industry and be completely clueless because of differences in how people use these things, talk about these things, think about these things. So we're trying to I mean, it's hugely important, and we're trying as best we can in the time we've got in the master's program to address it.
Yeah, and same in the undergraduate. We actually have concentrations that are both internal and external to the school as part of the curriculum. And so those concentrations are 3 classes in a domain area. So we have one that we're working on with neuroscience. We have another one with sociology. We have one with McIntyre. We have one with the education school, actually. It was the first one that went through. They focused on kind of educational concepts. So the idea, and this is kind of a little bit of the Berkeley model. There's things about the Berkeley program that I think we're doing better. But this part of it, the concentration areas are really great. So the idea is to have, maybe a couple dozen of those. And they're existing courses where students will take the knowledge that they've learned over the course of several years inside the school and then go apply it outside by taking an introductory course and then 2 higher level kind of data-oriented courses in that field. So again, we have the luxury of a bit more space. So we anticipate probably, students graduating with multiple concentrations. But the idea is exactly that, is to take the skills and actually see how they function in some unique area. Because data always comes from somewhere, right? It doesn't magically appear. So important to understand the field with which it emanates from. Yeah.
We're better than Berkeley in basketball, at least.
That's true. That's true.
Do you want to say?
Well, I'll just say, like in the PhD program, we do have that advantage of time. And so speaking about like UVA Health, it would not be surprising to see a PhD student who actually is working with a team at UVA Health for multiple years. And I think there's just some things that can't be learned in the classroom that have to go through that experiential learning that comes through just having time to do it.
I think from the broad perspective of the school, there's too many domains, right? So you can't teach all the domains. But you can teach how to be a team scientist, right, and how to engage through. And they may existential experience might be through health, but health is ginormous, right? You could be working with medical records, you could be working in genomics, you could be looking at radiology scans, you can be doing all the above, right? So part of that is teaching some skills that are transferable to other domains. And that goes along with this sort of foundations of what do you teach in data science as we're moving a little bit away from teaching you how to code this model to what does it mean? What's a model? What are the things that you would check with a model? That little bit of generalizability is helpful. It's also helpful for learning how to do that team science piece, I think. And so the school does have some emphasis and I think some goal of being able to do that. So, you heard Phil say the humanities he views very much as a partnership. Well, that's also, you can imagine, a domain science. But you have to learn how to interface with that domain science. The language is different as well. So that blending is hard, but you can teach it, I think, and it's an important part of what we're trying to teach. I want to I have to wrap up at this point, so I want to thank our panel and just a couple announcements before some applause. There's a lunch session that's immediately following this. I believe you can pick it up. It's right in that room. Then people will be coming back in here to eat and socialize. There are some information sessions if you're interested in one of our programs, bachelor's, master's, or Ph.D., and they're in other different rooms around the floor. And then immediately after lunch, there will be a series of breakout sessions again. And so thank you everyone for coming. Please join me in thanking our panel.
Thanks for checking out this week's episode. We'll be back soon with a new conversation. In the meantime, check out our previous episodes, which cover a wide range of subjects within the field of data science. And again, if you're enjoying the show, please leave us a rating and review wherever you listen to podcasts. And if you'd like to contact us, you can send us an email at uvadatapoints@virginia.edu. We'll see you next time.